This is TMUA Question of the Day, Day 23 hints with stopmaths.com and Tobin Payne. Our first question, so our A-Level Plus, is pretty easy question. You do get some of these on TMUA. With anything like this, always just double check that you haven't missed anything obvious. Don't just assume that because it's a cubic, it's got two stationary points, although it might. Don't get confused when you say stationary points and roots. Just any question that seems too good to be true, just double check that you haven't misread it. But you shouldn't have any problems with that one. Now, this one is our functions in algebra. When you've got an equation like this, it's worth having a think about why there would be a greatest possible. If I'm ever asked about a greatest possible value of x, y, a, b, whatever, I'm going to say, why is it? What about the function means that there's a maximum or a minimum? Well, because we've got the sum of two squares equals 1, obviously they can't get very large. Because if log 10 of b was very large, then we're going to have problems. And you could think of this, of course, as 4x squared plus y squared equals 1. And then you're trying to maximize x. Now, also, if you've got, obviously, our x is a function, log 10a. Is that an increasing function? Is it a decreasing function? Do we want a to be big? Do we want a to be small? Etc., etc. What do we want the value of log 10b to be? What do we want the value of b to be, etc.? Just really think about what functions are you using and how does that impact your goal. We then got our functions in geometry. Now, for whatever reason, I find a lot of students don't think of the word reciprocal when they see this function. Reciprocal graphs are interesting because of firstly, what is it possible for the denominator to be 0? Because if it is, there's going to be a asymptote somewhere. What happens as x becomes very large? What's going to go on with the denominator? If you've got to minimize a reciprocal function, you might have to maximize the denominator and vice versa. So lots of interesting questions and thoughts on reciprocal functions. What kind of function is in the denominator here? What do you know about that kind of function? You'll recognize, of course, this is a quadratic. What kind of form can you make with a quadratic? Sometimes students will want to use calculus on this question because they see turning points and they go, let's do something with calculus. Generally, if you've got a quadratic, there's no need for calculus. What is it you can do with a quadratic? That's an alternative to differentiation in order to find stationary points. And then finally, our logic question. Now, Tobin's note on this one, which I thought was very interesting, is how can you do something like this quickly? Because pretty much anyone could do this question given enough time, but it's how do you do it under those TMUA-like conditions without making an avoidable error, but without also spending your whole exam on it. So just one little hint here. Is there another way of writing, for example, S99? Could you write that as the sum of anything else? And therefore, can you start to collect terms quickly? So, for example, how many S of 2s are there? So a question like this, you want to develop a method for doing it quickly, but you don't want to just rush into the algebra. So the speed is gained by being considerate of what algebra you're going to do. Hope this video was useful. Feedback always welcome.